All right. Hey, welcome everybody. How are you? Welcome to your stay home, stay safe chemistry class with me, Mr. Picard. And hope you're all doing well and your friends and family are doing okay. And I'm so excited. I know it's hard to believe because we are going to dive into more information and learn more about the periodic table of elements. And I know you're fired up about that. Well, maybe you are. I hope you are. And I'm going to start with a bit of a confession. And there's two sides to this really. Is when I was in high school chemistry class, you might be glad to know that I did very well. But even though I used this periodic table of elements effectively and I got good grade, I didn't really understand it all that well. I didn't appreciate it, and I really didn't have any clue how much information was on here that I wasn't really aware of. I really didn't know how to read it. And I promised at one point in every class this year, I remember mentioning that I wasn't going to make you memorize the periodic table. I was going to make you memorize that, well, you know, what does the letters capital C stand for? I mean, you already know it's carbon, or some other aspect of it, like what's its atomic number? You might already know it's 6 anyway. But the point is, memorizing the table is silly. It is a table that's been laid out in a beautiful way. And it's beautiful because it's interesting and because every placement of each element has lots more information on it than, it's really hard to imagine. And it's critical, I think, to understand that the information on the table goes way beyond the information just in the square, or in this case on this card, you know, the atomic name, the atomic weight, and other aspects. It's all encoded in the patterns, you know, in the placement on this beautiful card. And, or table, not card. I guess the thing I'd like to do in my everyday class is make today a sort of connection between yesterday, today, and tomorrow. And in one of our yesterdays, we made cards. And we made our cards from experiments that we did. And you might remember, I hope you remember, that we tested 11 elements, and we found out how hard they were they malleable, were they reactive. We dropped most of them into hydrochloric acid to see if they would react with the acid. And we did what scientists and first alchemists did before even the table itself was made. And why were we doing that? Well, chemistry is in many ways, or maybe it's really a definition of chemistry, is the study of matter and its interactions. You know, the matter and energy and the way that substances come together and make new substances or come apart and form new substances. And it's really all comes down to what are the properties of whatever piece of matter we're talking about. And it turns out that the smallest piece of matter that has the properties of a piece of matter that can't be broken down any further by chemical means is an element. And so we have elements. And the way they interact is based on their properties. So what's amazing about the periodic table is it lays out all the known elements. And right now there's actually 118. So the full table looks like this. There's 118 elements. Only 92 up to uranium is found in nature, and there are no more stuck in between there. After 92, there are synthetic elements that have been made in laboratories up into 118, which is about here. And maybe there's more, maybe there's not. On the table in front of us are about 40, I think, maybe 40 elements. And I've laid them out into the same groups that are found on the larger table. This is just some of the groups I've left out. So let's turn this around. And I don't expect you guys to be able to read what's on here. You're going to do that after you watch the video. But I can point out some features of the table to you this way. So now it is oriented more, towards you. And we call each of these columns going this way a group. And in each column or group, and we've numbered them, 1, 2, 3, 4, and they keep going on the big table, right, all the way up to 118. And here we've got a few that we've dissected out. But each column has a group, and the group is there, just like when you made, so that would be the yesterday. When you made your groups, you also put elements that you found had properties in common in a column, like this. And interestingly enough, we sometimes call those families, which is kind of confusing. I mean, why is this called the alkaline earth metal family? Well, this family, there's another family. This is by the way, the halogen family. This is the noble gas, which is considered a family. And there's some other ones we're going to study, group 1, in our experiments later. I'll tell you about that. But let's say for this group, why is this group together? Well, alchemists and scientists had figured out the properties of these elements and had grouped them together long before there was a table. So when the table got made, some of these groups, known previously as families, were already in existence. So they still remain having this sort of dual name of as well as a number going 1 to 18 across. So that's just a way of finding a column. There are other things that are continuums that go up, that change slowly as they go across, like this, and then keep going. And I suppose that's a little bit like a calendar, right? In a calendar, you're going to start with maybe Sunday, Monday, Tuesday. By the way, what day is today? I'm finding that pandemics is really hard to keep track of days of the week. I think it's Wednesday, and I think it's the 7th, So anyway, there's a progression across, as well as commonalities going up and down. There's also trends, and that's one of the most fascinating things about the table, is that there are certain trends that increase, maybe going this way or maybe going this way. We even have some trends that move across the table at an angle. And so where something is placed can reveal a lot about its properties. If you can predict an element's properties, you can predict how it's going to react with another element, and that's chemistry. You can start to manipulate that, build things, predict things based upon the information in the table. So I'm going to ask you to print out the copy of I put a PDF online for you to print out. You could also maybe open it up in a window on your computer, but I want somehow to have the full periodic table in front of you and go to the first quiz. The other thing you want to look at that I posted was I took a photograph, high resolution photograph of this table here. And it's good enough so that you'll be able to see the information inside the card. And every card has the element name in the center, actually its symbol, a 1 or 2 letter code. This is B for boron. and as well as information in all the corners. And you'll be able to zoom in and read that. And you're going to need that information to do the quiz I'm going to post. Then I've done experiments with this group 1, and I videotaped them. And you can take a look at those. Those will be posted in a subsequent update on Schoology. And then there's a second set of questions. The first quiz is only like 4 questions, but you will need to also open up the periodic table and the photograph I took of this. All right, good to see you all, well, sort of, and I'll be back in touch.